Okay, so I am going to discuss now the MCQ 2 mark solution. There will be 20 questions, I guess. So it will be a long video. I mean, it will take some many time. So let's just start the video. Okay, so it is JAM 2025 2 mark solution, MCQ 2 mark solution. Okay. So first question, in the circuit given below, the frequency of the input VIN, that is 10 to the power 4, omega is 10 to the power 4. So the output voltage VAB leads VN by what amount? So you have to calculate the phase VAB with VIN. Okay. So they are parallel. Okay, this is a RL circuit, this is RL circuit, and this is a RC circuit, and they are basically parallel. So this experience the same VIN, and this circuit also experience same VIN. So we basically have to found the what is VA in this circuit and what is VB in the circuit up to the phase. I mean, not the magnitude, but we have to find what is happening to the phase. Okay. So now for the RL circuit, let's note that R is equal to 10 ohm. And what is XL, the inductive resistance? It is simply omega L. So omega is 10 to the power 4 and L is 10 to the power minus 3 because it's 1 millihenry. So 10 to the power minus 3. So it is also 10 ohm. Okay, so now you know that the phase difference, that is cos theta, is equal to R by Z, or you can also say that phi is tan inverse XL by R. Okay, so this is the phase. So cos phi is R by Z. Okay, so this is basically 10 by 10, that is 45 degree. Okay, so now what is this phi? So this is the phi if current is flowing through a RL circuit. Okay, so this current will lag the VIN by this amount. So current will lag by 45 degree with VIN. Now what happened for the RC circuit? Okay, so for the RC circuit, let's note that R is again 10 ohm, and uh, the XC, that is capacitive reactance, it is 1 by omega C with the, I mean, there is a iota there, the imaginary part is there, but I am taking only the magnitude now. Okay, so it is 10 to the power 4 into 10 into 10 to the power 6 because it is 10 microfarad. So 10 into 10 to the power minus 6. So 10 to the power minus 6 will go up. Okay. So it is again 10 ohm. Right. So this time phi 2, the phase difference is also 45 degree. But remember, if current is I in this circuit, let's say it is I1, I1 and this is I2, this will lead the VIN. This will lead the VIN by 45 degree. Okay. Now what is VA? If you calculate this point and this, if you go around this loop, okay, go around this loop. So VAB basically is I2R. Okay, so it is I. This is current flowing here, current flowing here. I1R. Okay. So R is basically same. What is your I2 and I1? I2 and I1 is both are VIN by and Z. The magnitude is Z is same for both the circuit because XC and XL are 10 10. So Z is basically root under 10 square plus 10 square. So 10 root 2. So you don't have to care what is I1 and I2. They are basically same. That is the thing you know. Okay. But this phase is this in this case phase is lagging by VIN, lagging with VIN by 45 degree, and in this case the phase is leading by 45 degree. So the overall phase difference will be 90 degree. So we had 45 degree lag, and here 45 degree. So in this case it is 45 degree lag RL circuit, and in this case it is 45 degree lead. So overall difference is 90 degree. Okay, so it is a good problem. Okay, this is a simple problem. Just a simple calculation. You have to calculate df dt at t is equal to 0, and it is given x is equal to 80, y is equal to bt. Okay, so t to the power bt plus t to the power 80. So just take the differentiation and put t is equal to 0. Okay, so you will just, I mean, I shouldn't do that. You can solve it. Okay, so it will give you 2. Okay, so this is another problem that you have a solution, that is you have a matrix uh, 1 m a 2 a m and a2 minus 1, and you have some x y z. We want to calculate the value of x y z. Okay, so and it is 0 0 0. Okay, so what is your x y z? So x y z is that inverse of this. So the same, there is some cofactor, the matrix cofactor with these cofactors, and there is 1 by determinant, and this is 0 0 0. Okay. So it is given that it's a non-trivial solution, not trivial solution. That means you don't want x is equal to y is equal to z is equal to 0. Okay. So you want a non-trivial solution. So to get a non-trivial solution, see, these things are 0. So if this all these quantities, I mean, you can guess that you have to put the determinant is equal to 0 and you will get your answer. Okay, so the answer will be this. Just take the determinant and you can easily solve it. There is nothing to do. But thing you should know that why I am taking the determinant is equal to 0. Why I am taking determinant of this matrix is A. So why we should take data is equal to 0. So suppose there is a matrix, this matrix. I am telling about this matrix. All the elements are non-zero. Okay, and you are multiplying with a 0 0 0. So you will get a column matrix which is 0 0 0. So you will get a trivial solution, that is x is equal to y is equal to z is equal to 0. So if you assume all the elements here are non-zero and you are multiplying with a 0 0 0, you will get x is equal to y is equal to z is equal to 0. It's a trivial solution. But you don't want a trivial solution. You want a non-trivial solution. Okay, that means 0 by 0 form kind of thing. Okay, so if you get some 0 by 0 form, then you can get non-trivial things only. Otherwise, you will get x is equal to y is equal to z is equal to 0. Okay, that's why we are taking the determinant of this is equal to 0. Now I'll quickly take the determinant. I mean, you can easily solve it, but let's do it. Okay, so minus a minus 2m minus m minus 2 minus am plus a into 4 minus a square is equal to 0. So 4a minus a is equal to 3a minus a cube plus a m square is equal to 0. So uh, a into ma square minus a square is equal to minus 3a. So ma square minus a square is equal to minus 3 is one solution, but if a is equal to 0 also a possible solution. Okay, so you are given this, so this will be the correct option. Okay, this is a simple problem. What is the minimum value of n? So you just have to remember your basic class 11 calculation of complex numbers. So 1 minus I by 1 plus I, just multiply numerator and denominator with 1 plus 1 minus I whole square divided by, if you multiply it with 1 minus I, it will become 2. So it is minus 2I by 2 is equal to minus I. So minus I to the power n by 2. Just quickly check. If you put n is equal to 2 by 2, that is 1. So minus 1 I to the power 1 is equal to 1. If you put n is equal to 4, that will be minus I square. That is minus 1. Okay, so satisfying. So 4 is the correct answer. Okay. Okay. Now u is this, v is this. You have to transform this xy to r theta polar coordinates and Jacobian of this uv with respect to r theta. Okay, so u is half x square minus y square. Now x is equal to r cos theta, y is r sin theta. So it will be half r square cos square theta minus sin square theta is equal to cos 2 theta. Right? And v is r square sin theta cos theta, but sin theta cos theta is nothing but sin 2 theta by 2. So it is half r square sin 2 theta. Right. Now take the Jacobian quickly. So it will be r cos 2 theta del u del r del u del theta, that is minus r square sin 2 theta del v del r is r sin 2 theta, and del v del theta is r square cos 2 theta. So you will get some cos square plus sin square. So theta will not appear in the solution at all. So you will simply get r cube. Okay, so r cube. Yeah. Now let's move to next one. I guess 16. the all the options are not visible, sorry for that, but you know the options. Actually you have the questions and the response sheet, so you know the options, so better look at the solution, not at the options. Okay, so three particles of equal mass m interacting via gravity lie on a vertical vertices of equilateral triangle of side d shown in figure. The whole system rotating with an angular velocity omega about an axis perpendicular to the plane of the system and passing through the center of mass. So suppose there is a center of mass here and the axis is passing through this center of mass. Okay, so this is the, suppose this is a jet plane and this is rotating about this axis. Okay, so you basically have to calculate what is the, I mean, if it is rotating like this, so what is your r basically. Okay, so this distance, they are basically r, your r. Okay, so what is your r at first point? So r is basically 2 by 3 into height of the triangle. Okay, and 2 by 3, I remember by this way, you can remember by other way. Okay, so and height is root 3 by 2a, so it is a by root 3, sorry not a, it is d is given, so d by root 3. Yeah. Okay, and what is the net force on this mass m? So it is experiencing a force F here, a force F here. Okay, so net force F net is equal to 2F, and what is this angle? This angle is 30 degree, so 2F cos 30. So it is basically experiencing root 3F. And what is F? F is equal to gm squared by d squared. So now simply equate the two. So m omega square r, that is d by root 3, is equal to F net, that is root 3 jm squared by d squared. Right. So what will you get? Omega is 3g m by d cube. Okay, so probably option B or C. So this will be the answer. Omega is equal to root under 3 gm by d cube. Yeah. Now let's move to next. Okay, so maybe acha. Okay, I forgot 17, 18, but it will be in the last of the paper. Okay, so I will do it. Okay, so no matter. For a two slit Fraunhofer diffraction, each slit is 0.1 mm wide and separation between the two slits is 0.8. So the interference minima, total number of interference minima between the first diffraction minima on the both side of the central maxima. Okay, so first do the what is a and b. So a is 0.1, b is 0.8. So a plus b by a is 9. But what is this number a plus b by a give you? So you may incorrectly tick this 9 into 280, but correctly interpret that what is in actually, what is a plus b by a 9 actually giving you. So this is suppose the first diffraction, not it like Gaussian, it is sine waves, but okay. So this is the first minima, and there is interference maximus and minimus. Okay, so like this, like this. So for this diagram, let's say this is the central, this is first, this is second, this is third, and there should be another, but this is missing. Okay. So a, what is the value of a plus b by a for this case? The fourth order is missing. Okay. So a plus b by a is 4 for this diagram. Okay. Similarly, there will be three, 1, 2, 3, and again the fourth is missing. Okay, so fourth one is missing, three are present. So if ninth is missing, then eight will be present here. Eight will be present here. So let's count if you don't agree with me. So one minima, two minima, three minima, four minima, five minima, six minima. So a plus b by a is equal to 4, then fourth order is missing. Then in both sides you have 3 minima, that is 6 minima. Okay. So similarly for this case, in this case you have 8 minima on left side, 8 minima on right side. So total 16 minima. Okay. So be careful. Okay, and this is a simple problem basically. So phi is equal to pi, the resulted motion will represent this. So you can just simply have to substitute things. Okay, so y1 is equal to a cos 2 omega t. So 2 cos square omega t minus 1, and y2 is minus b cos omega t, but doesn't matter because we will square it anyway. So 2 cos square omega t is y2 square by b square minus 1. So what is this equation? It is something y squared is equal to 4ax plus b into some constant. Okay, so this is like a parabolic equation. Okay, 21 the options are not visible, but let's see the solution. Okay, so this is a conceptual question, and I will strongly recommend you to, if you are not familiar with this, so again, there is big Ghosh, a textbook on light, textbook on light, polarization, and polarization by refraction. Okay, polarization by refraction, read this part. Okay, so an unpolarized light ray passing through air n is equal to a incident on a glass slab of Ng is equal to root 3 at an angle 60 degree. Okay, so the amplitude of the in plane, that is xy is this direction, this is xy, so this is the xy, so something electric field in this direction, they are xy. But if something is perpendicular to this direction, that means z direction, so it will in this direction. Okay, so XY electric field component of incident light wave is 4 volt per meter, and the amplitude of out of plane, that is Z, that means the perpendicular component, the perpendicular to the plane. I mean, if you represent like magnetic field, so this is the perpendicular to the plane representation. So some electric fields are perpendicular to the plane. Okay, the Z component. Okay, so after passing through the glass slab, the electric field amplitude of the light. So something will reflect, something will refract, and you will immediately, guess or calculate that tan theta is equal to n satisfying here, because tan 60 is root 3 is equal to satisfying here. Okay, so it is incident at Brewster's angle. Okay, so there is 90-degree phase between reflection and refraction. So now the concept is that this is perpendicular to this, and electric field is also perpendicular to this. Okay, so in this refracted portion, electric field can't be in the xy plane. So for the refracted light, electric field can't be in the xy plane, it will only be in the z direction. Okay, so it will only be in the this direction. That's why this is giving a polarization. This is called the polarization by diffraction, concept of polarization by diffraction. So you will get a plain polarized light whose electric field is only in z direction, perpendicular to the direction of this plane. Okay, and for this light, obviously the one part is gone here, so the left here is only the parallel part. So in this light there are both, there are parallel and perpendicular. When it is refracted at Brewster's angle, this refracted ray only consists of the perpendicular component electric field, and this reflected ray only consists of the perpendicular component of electric field, and the refracted part only contains the parallel component of the electric field. That means the parallel part is 4 volt per meter, so it have only the 4 volt per meter, and it has only the 3 volt per meter thing. Okay, so they are asking that after passing through the glass slab, so for this medium they are asking, so it is 4 volt per meter only. Okay, so the 3 volt per meter, which is the perpendicular component, this is gone to the reflected part. Okay, so this is a good concept, polarization by diffraction concept. Okay, yeah, so now let's move to this problem. Oh, this is also a simple problem actually. So they mentioned the plate area, the electric field between the plate area, and they are telling you to calculate the magnetic field at the periphery of the capacitor. Okay, so you would simply know that del cross B is equal to mu E del T. Okay, the fourth Maxwell's law, the correction to the Maxwell's law, actually displacement current law. So B dot dr, del cross B dot ds. I mean, del cross B dot ds will give you B dot dr is equal to mu E del E del T into ds, right? So it will be mu naught epsilon naught, and del E del T is what? Omega E naught cos of omega t. ds is simply a, and what is b is simply divided by 2 pi r, but be careful, they are giving you the area. So pi r square is a, so r is equal to root under a by pi. So you have to substitute this as also, r is equal to root under a by pi, and mu naught e naught is equal to simply 1 by c square, right? So you have to substitute this. and finally you will get this answer. Okay, next one. Okay, so the surface current density is given on a strip with b y is equal to say 0 y is equal to b as shown in the figure. So the associated surface current, so it will again simple integral of k dot dy, because k is a function of y, it is varying in y direction. Okay, so it is 0 here and some varying k to the power minus b here, so varying here. Okay, at sorry, a to the power minus b 0, so varying in the region. So you have to simply integrate. Okay, so a to the power minus y dy 0 to b. Okay, so the integration is simple and you will get this answer. Okay, so this is also a simple problem. Okay. This is actually a complicated problem, because not complicated if you know the formula, and complicated if you don't know the formula. I mean, you have to leave it. So the formula is del cv del vt is equal to t del 2p del t2 at v. And how this formula is coming? This is coming basically from this. I will uh, partly show you, try to show you that how this formula is coming. So del p del t, right, at constant v, right. Now take another derivative. So del t of del s del v t whole of this with v will give you del 2p del t to v, right. Multiply it at t both side. Now you change this order of integration. So del v of t del s del t at v with t, right. This is your t del 2p del 2 del t to v. Now what is this quantity t del s del t at constant v? This is nothing but cv. So your del cv del v at constant t is basically t del 2p del t2 at constant v. Okay, so this is your formula. Now simply apply this formula here. Okay, so a t by v square plus b t cube by v. So if you take the double derivative, so the first term will gone away because it is linear, and the second term will 6b t by v square. If you multiply it with a t, it will be t square. So this is the expression for your CV. They are only asking about proportionality. So t square will be the right answer. Okay. This problem 24, for an electromagnetic wave, consider electric field corresponding magnetic field is. Okay. So the right formula, I am giving you the right formula, but not always you should remember this formula in exam hall. So you sometime use your intuition or trick. Okay. So look at the options. So all the options are visible to you, and you know your pointing vector direction, that is k direction, the traveling wave direction, should be electric field cross magnetic field E cross B. The direction I am telling only about the direction. The direction of the pointing vector, direction of k should be the direction of E cross B. Now what is the direction of E here? E is k cap. Okay, so here it is k hat. This, no, don't confuse with this k. I am trying to, this is pointing vector direction. Okay, you don't know B, but what is your S direction? Okay, S direction is simply your I hat plus J hat by root 2, right? What is your S direction? It is A x A dot, I mean your k dot r is the format, and your k is suppose a I hat plus b a j hat by root 2. So you will get ax plus ay by root 2. So this is your s vector direction, and you should have a b which will match these options. So now check these options. All the options are different. Okay, there is nothing similarity. So try to match. So what is your k hat I j k cyclic way? So k cross I will give you a j, and k cross j will give you a minus I. That is the philosophy. Okay, so k cross I will give you a j, k cross j will give you a minus I, minus minus plus. So option A is matching. So you don't even need to do all this strong stuff of doing step by step. Just match the options whether the direction is matched. Okay, next one. Okay, so again this is I mean straightforward problem. You have to guess the potential. Okay, So you have to take the second derivative. So I am taking this alpha and e to the power gamma t by h cross as a constant c because it will not affect the derivative. Only the difficult part is e to the power minus 2 beta x by x square. So let's do it carefully. So d phi dx is equal to c x is e to the power minus 2 beta, not e to the power minus beta x square e to the power minus beta x plus 2x e to the power minus beta x, right? So it is c e to the power minus 2 beta x into 2x minus beta x square, right? Now d2 phi dx2 d2 phi dx2 is equal to c to, I am again writing this as 2, sorry, e to the power minus beta x. Take this derivative 2 minus 2 beta x plus 2x minus beta x squared into minus beta into e to the power minus beta x, right? Now remember the form. Remember the form. It is d2 phi dx2 is equal to e minus v into phi. So looking at, you have to solve for v. Okay, so you have to divide phi in the both sides. So if you divide phi on the both sides, so you have to divide by this quantity. So cc will, if you divide by phi, 1 by phi d2 phi dx2, cc will cancel, e to the power minus beta x will be cancelled. So you will simply left with 2 by x squared minus 4 beta by x plus beta square, right? So this is the quantity we left with, and if you arrange this you can eventually get this option. Okay, so nothing complicated, but do the differentiation carefully, just it. Okay, so this is I mean a bit good problem, but you nothing worried about it. But look, the options looking very complicated, so don't get brainwashed by it. So problem is easy actually. So consider a relativistic particle of rest mass 2a moving with speed v along x direction. It collides with another relativistic particle of rest mass a moving with same speed but in opposite direction. Okay, so here is a particle 2m moving with v. Here is a particle a moving with v opposite direction. This particle collapsed and, sorry, the language is not clear to me. I mean collided actually to form one particle whose rest mass is m. Okay, so they are formed one particle. So first, the obvious thing is the linear momentum conservation and the energy conservation. Okay, so now gamma, let's say this has gamma is equal to what? 1 by root under 1 minus v square by c square, and this has same speed. So this two has same gamma. So you don't worry about it. What is gamma for here, gamma for here? These two are same gamma. So the net momentum after the collision is, this is 2m gamma v minus gamma mv is equal to gamma mv. Okay, this is p. And what is the initial energy? Initial energy is equal to gamma 2mc square plus gamma mc square. Gamma are same, the rest mass are different. Okay, so 3 gamma mc square. And you know what is the momentum of the resultant particle. So just apply the formula, E square is equal to p square c square plus m square c to the power 4. That's it. So 9 gamma squared m square c to the power 4 minus gamma square m square v square c square by c to the power 4 in root under is equal to m. So c to the power c to the, take m outside, it will be 9 gamma square minus gamma squared sorry, a might take already outside, and this is v square by c square term left here. V square by c square is nothing but beta square. Beta is b by c. Beta is b by c. And what is gamma square? So it will left with 9 minus beta square, and gamma square is nothing but 1 by beta square. Okay, so this is the option A. Okay, this is also a good problem. I mean, nothing looking complicated, but nothing to worry about. So, two non-relativistic particles with mass m1 and m2. So, note point to be noted here that two non-relativistic particle. So, don't confused. Okay, it is non-relativistic. You can apply Galilean relativity to these particles. Okay, move with momentum p1 and p2 respectively in an inertial frame S. Another inertial frame S prime moving with a constant speed with respect to S. Particles are observed to have p1 prime, p2 prime. So Galilean, they already mentioned. I don't see that Galilean invariance implies that. Sorry, I don't see this line initially, but okay. So if you confused with S and S prime, you may think that special relativity will apply, but not. It is Galilean relativity. Okay. So in frame S, it has some momentum. P1 is equal to m1 v1, and p2 is equal to m2 v2, and another S prime is moving with say V. So what is your P1 prime? P1 prime is simply M1 into V1 minus V, and P2 prime is equal to M2 into V2 minus V, right? So multiply a M2 here, a M1 here, a M2 here, a M1 here, and subtract these two. So M2 P1 prime minus M1 P2 prime is equal to M2 P1 minus M1 P2, because this V term V has M1 M2 coefficient, so it will cancel. Okay, that's why we are multiplying this. Okay, so option A will be correct. Now 17. Okay, so the binding energy BAZ of atomic nucleus A and atomic number Z, neutron number N, can be expressed in this form. Okay, so A183 approximate dimension constant. Okay, so let BAZ prime be the binding energy of a mirror nucleus which has same A but number of protons and neutrons are interchanged. Okay, so what will be BAZ minus BAZ prime? So let me give you an example. Suppose a nucleus has 17A33, let's say, and a nucleus has 16A33. Okay, so the mass number is same. How many number of protons and neutrons are here? Proton is equal to 17, neutron is equal to 16. How many numbers of proton and neutrons here? Proton is equal to 16, neutron is equal to 17. So they are just interchanged. So these are called mirror nucleus actually. Okay, so to solve, so now the difference between these two you have to find. The first thing you should know that A are same. So these two terms, the first term and the second term, only contains A. So these two terms even not contribute if you take the difference. Okay. So the confusion will be in this term and this term. Now carefully note this term A minus 2Z. What is A minus 2Z? A minus Z minus Z. A minus Z minus Z. Okay. So it is N minus Z basically. Now take this example. So the first case N minus Z will be 16 minus 17 is equal to minus 1. The second case, in this case, N minus Z will be 17 minus 16, that is equal to plus 1. But you are taking square of this, so both of them will be plus 1. So if you take the difference, then this term will nothing contribute. Okay, this term also doesn't contribute. Okay, so the only contribution is from this term. Okay, so one has Z, one has Z, so the difference will be proportional to Z square minus Z prime square. Okay, so this has Z, this is Z prime. Now Z prime is simply N because neutron and protons are interchanged. Okay, so this Z prime is simply A minus Z, nothing but N. Okay, so as they are interchanged. Okay, so 6, 17, 16, 16, 17. Okay, so it is proportional to Z square minus N square. Okay, this is also a straightforward. Okay, so magnetic field is they already give the formula of magnetic field. They give some form of a vector. Okay, the vector potential, and you have to find the current density. So you basically have to take V is equal to del cross A, and del cross B by mu naught is equal to J. This way you can find the J vector. Okay, so I J K del X del Y del Z. Okay, and there is ax square plus by squared 0 0. So this term, the b is this. So b is this. B is minus k hat, only you can find that this term will 0, j component will 0, so it is minus 2by. Okay, so that is minus 2by k hat. And if you again do a del cross b, I am not doing that, but you can obviously do it, so this will be the answer. Okay, yeah. Now 90. 18 and 19 I forgot actually initially there, so these are the two. Okay, yeah. So one end of a long chain is lifted vertically from flat ground to height h with constant speed v plus force of magnitude f. Assume that the length of chain is greater than h, then it has a uniform mass per unit length rho, so magnitude of force. So the thing is like you have a chain initially in the ground. Okay, so chain initially in the ground. Now you start pulling it. So some part is left still in the ground and some part is here. Okay, so you lift it with some height. Okay, so what will be your force? You will lift it with a what is the uniform mass and force magnitude is f, and what is the constant speed v. Okay, so you can assume this similar situation like if you have this configuration and you left this you first hold this chain by your hand and then you release this chain, it will eventually come to the ground and it will exert some force. Okay, so what will be the force it will exert? Okay, so let me write it. You may not know it, but it is a famous. In classical mechanics, it is very popular. I mean, many books have this kind of problem. Okay, so decrease in potential energy per unit mass, that is mgh divided by I mean the total mass is not m, so this is the mass here content here by the displacement this length, so it will give you simply rho gh plus the thrust force, this is called thrust force, that is rho v square. Okay, this is called the thrust force because of the velocity it gained. Okay, so this will be the correct option for this question. Now this problem, the last problem, the two masses m1 and m2, these are connected through a massless spring of spring constant k as shown in the figure below. The mass m1 is at rest against a rigid wall, so it is against a rigid wall, and m1 m2 and then on a frictionless surface. Okay, so the mass m2 is pushed towards m1 by a distance x from its equilibrium position, then released. So after m1 leaves the wall, the speed of the center of mass. So they are basically telling you that you pushed it little bit and then again it will come back to its original position and again it will go further. So at the moment when it is leaving the wall, then you have to calculate what the velocity is. So when you push it, suppose you have already pushed it, it has some compressed thing, then it will get to its original length and it will come back to this position and acquire some velocity because of this compression. But at this time when it's come to original position, then it will feel the tension and start moving in this direction, the m1. But until that, until it come to its original position, this m1 will feel nothing. Okay, this spring is compressed, then again extended to its original length, then it will start feeling then the m1 will start feeling the effect. Before that it will not start feeling any effect. Okay, so initially half k when if it is in the original position, when m2b will in the original position and m1 is just about to start its motion, m1 is just about to leave the wall, for that moment, until that moment m1 has no velocity, so it is m2 v square at that moment. So v is simply root under k by m2 into x. So what is the center of mass velocity at this moment when m1 is just about to leave the wall? So it has still zero velocity. It has m2 into v divided by m1 plus m2. Okay. So it has root under k m2 x divided by m1 plus m2. Right. So options is not visible here, probably B or C or whatever. This will be the option. Okay. So I guess all the options are correct given here. Maybe I am doing some mistake somewhere. It may be possible, but I felt all the options are correct and some of the problems are good standard. What should be the level of jam actually? Okay. So yeah, that's all the solution for 2 marks and probably the MSQ and the part one MCQ 1 marks are left. I will upload it in the night. Okay. So yeah, thank you.